Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and we are talking today about Aneutronic Propulsion. Hey, Ben, how are you?
Hey Simon, how's it going? Hey fellow Econauts. Yeah, today I want to talk about Aneutronic Fusion Propulsion to be more precise, and what it is, what we can do with it, and what impact it would have on our society.
Well, you already took away my first question. What what exactly is Aneutronic Propulsion?
Well, I thought I'd make a soft preparation
Soft,
for this
soft,
hard
okay.
topic. Well, I mean, first of all, let's just dissect the word a little bit. The word aneutronic means that there are no neutrons emitted from the process, and fusion obviously is when you fuse elements together. In that process, as many people would know, you generate a lot of energy, and that energy could be harnessed. If you can direct or guide this energy, then you could use it as a propulsion. So here comes the beauty for the classic or the for the normal fusion. When you fuse, for example, deuterium and tritium together, you generate lots of neutrons. The problem with neutrons is they are not charged, and therefore you can't really control in which direction they are going. So they fly in every direction. And therefore, you can't really do a propulsion with that. With a neutronic fusion, you generate charged particles. And these charged particles, you could contain them in an electromagnetic field and therefore guide them in one direction. And this is how you get the propulsion with it, because now you expel mass with a very high velocity in one direction. That means you go in the other direction.
What kind of fuel would we need to actually build such an engine?
Yeah, so as I said, so for the classic fusion, you use isotopes of hydrogen like deuterium and tritium. But for a neutronic fusion, there's other exotic mixtures necessary. One of which is you could do a pure helium-3 fusion. And that brings us back to we have helium-3 on the moon. We could use that. I think there's an estimate that 1 tablespoon of helium-3 contains enough energy to run an American city with electricity if we were able to use it for fusion, that is. But yeah, so that's one thing. And yeah, obviously we could use it for the propulsion. And also one thing I might have not said before, the propulsion we would get with that is so fast we can actually nearly reach the speed of light with a vehicle that is propelled by electronic fusion. So I think there was the Icarus mission in the 70s from NASA. Never really they never really flew, but they wanted to find out what would be needed to actually reach another star system, interstellar. We have talked about that as well, within the lifetime of a human being, and that was the Icarus mission.
The interesting part that I just gained from this little conversation is we talked about helium-3 in our episode about the moon, and also when we talked about Artemis, if I'm not mistaken. And yes, you are right. We also talked about fusion reaction when we were talking about interstellar travel. So we would actually unlock all that by having like helium-3 available. Is that more or less correct?
Well, I mean, let's put it this way. In the moment, we have next to no helium-3 available on our planet. So if we would like to do any experimentation with it, we couldn't even do it. We could only simulate it because we have not enough helium-3 available. But if we somehow suddenly had a huge amount of helium-3 available, say we would harvest it from the moon and bring it back to Earth, um, suddenly we would have so much helium-3 available, which by the way is already very expensive because of that rare occurrence on our planet. I think it's in the moment per liter under standard atmospheric pressure is like almost 3,000 US dollar or something. So it's very valuable because we don't have much. But yeah, so if we would have that available, it would unlock lots of research in many areas, one of which could be aneutronic fusion. And the beauty is, when you look at how we actually make electricity, we have solar panels. There's like photons get sort of in that PNP panel transferred to electricity. And all the other forms of electricity we have is literally just moving a wheel and then spinning in a turbine. Like all the other forms, like wind turbines, it's in the name. When we have even a nuclear reactor, we heat water up, the water flows because of the heat, and we run a turbine. So all the other forms of how we make energy, how we make electricity, is through some form of a turbine. With aneutronic fusion, because these particles are charged, we could extract the electricity right away. We don't have to go through a heating process. We could do that additionally, because there's also a lot of heat generated in the process, but the particles alone would already generate our electricity as well.
We could, in theory, we could have like a farm because the helium-3, it's like, I don't know exactly the process, but because of the sun and because of the circumstances of the moon, it is basically something that's like recreating, like I like a farm, basically, like wheat, basically. Is
Right,
that
it's renewable.
do
Yeah,
I,
it's completely correct.
I
Yeah.
remember correctly, right? So
Yes. Yeah.
helium-3 could be a resource if we are actually able to build, a sustainable base on the moon. Is something that we could harvest, and actually, if we can do that, then automatically it's get cheaper too, because if we have more
Well, yeah,
available.
over time, yes, over
Yeah.
time, yes. But look, first of all, we need a pathway. We need a highway to the moon, right? The moon then would act as as a collector. Other than we talked about the moon as a platform to launch to other planets, because we don't have to expel so much propellant to launch from the moon. But other than that, the moon is always flying in space. The moon has no atmosphere. The moon has no magnetosphere as well. So all the solar winds are penetrating the solar soil, the not solar soil, the lunar regolith at all times, and therefore penetrate them with the energy and the particles necessary to form helium-3. So the helium-3 will always be renewable in the soil, in the regolith of the moon. And yeah, so it's a bit like a farm. It's like on our Earth as well. We need sunlight to grow plants. So we would have something similar on the moon, but we wouldn't grow plants. We would just wait until a certain patch of regolith has been replenished with enough helium-3, and then you have to filter it out of the regolith, which I think, if I remember correct, you just have to heat it up 100 Kelvin over ambient temperature, which is next to nothing on the moon anyway, and then you can pretty much get it out of the regolith, and that's it. And then you just have to collect it, and if you have that highway to space, you have to bring it back to Earth, and then you
And
could use it.
you mentioned that we don't even need much to actually build a fusion reactor. I mean, a tablespoon, it's like
Well,
nothing. I mean, of course,
well,
it's like in theory, I understand that, but
yeah.
still, it is an amazing idea to think about that we don't really need much to actually unlock, I would say, like the next level of
Yeah. I mean,
technological evolution.
to put this statement a little bit into perspective, first of all, we don't know how much mass actually is necessary to have a sustainable and continuous fusion reaction. So even though 1 tablespoon in itself might contain that energy, maybe the whole process, we don't know enough how to run that process. We don't know how much we need to run that process. So it's different to the tokamak, and even that is not even completely understood yet. So first, second thing, uranium also contains a lot of energy, and our problem, our humanity's problem is, as I just explained, usually when we have something, we use it to heat up water to run a turbine. In that process, we have already so much energy loss. And that's the problem we have with nuclear energy, with fission energy, that because of the process, we heat water and we run a turbine. With aneutronic fusion, we might have that opportunity that we also harvest the electricity straight from the particles because they are charged. So, but how much we can actually harvest, if the apparatus we have can harvest all the energy, there's an effective an efficiency factor involved. So as with everything in physics, we can't beat thermodynamics, but there will be losses. But if we were able to take a tablespoon of fusion of helium-3, and we were able to extract that energy from that tablespoon, then the statement would be correct.
These are definitely interesting thought processes, and I cannot wait. I, I just have to ask that last question. Do you think that we can actually still in our lifetime see fusion reactors? Or do you think that's still too far away? Because I know that there are experiments. Some have been even very close, even some here in Canada, by the way. But I'm not really certain because many of those information are also, sealed. But what do you think? Do you think that we can actually see that in our lifetime
Well, I mean,
without?
we have fusion reactors already, and they are sort of working. The problem we currently have is there's a certain the fusion reaction has to be sustainable. If you have to put energy into the system so that it runs, then that's not what we need. So on a bench top, we can make a fusion, right? We know how to make certain types of fusions going. The problem is to get that chain reaction that it now is self-sustaining. The other thing is also, and that's my personal view, with the classic fusion, with the tokamak style fusion, because of all the neutrons expelled, they always penetrate the hull, and they have to rebuild the whole facility at some point because the whole properties of the hull to be superconductive and so on, that get lost with the penetration of the neutrons. So will we see that? Will we see that we harvest energy from fusion? I think the best answer is I don't know. I hope we will. I think we need a lot of more effort in this direction to make it work. Even international, like different countries working together. And tokamak is an international collaboration in France. Just on a side note. But yeah, I think I have a circular argument here. It's a bit like a politician. I don't know, but I would like to see it. So I guess that's the best I can give you here.
Yeah, it's definitely something that is like interesting to think about. It would, solve a lot of energy problems. I think we dived really deep into this fascinating topic today. If you liked this topic, please don't forget to leave a like and subscribe if you haven't already.
And hit that notification bell. Also, we have older episodes which you can look up in our library. Especially now today, would recommend the one about the moon, obviously, and about helium-3, which makes sense, I guess.
And of course, the
interstellar
interstellar,
travel. Yeah, yeah, of
interstellar
course.
travel might be also
Yeah, yeah.
interesting. All right, and also don't forget to leave a comment. All right, have a good day. Bye bye.
Bye.